Mars has an open wound that won't heal. Unlike Earth's canyons, which were patiently carved by rivers, Valles Marineris is a violent fracture. The planet's crust literally tore apart when Mars was young. We're talking about a gash 4,000 kilometers long where mists, clouds, and landslides the size of entire countries can fit. In the coming hours, we will descend into this red labyrinth where light takes minutes to reach the bottom. It's not just a landscape, it's evidence of a cataclysm. Who was the first to discover the colossal Valles Marineris on Mars? The answer is not an explorer with a helmet and flag, but an unmanned spacecraft, the Mariner 9 probe. In the early 1970s, humanity was still learning to take a close look at other planets. In 1971, Mariner 9 became the first spacecraft to orbit Mars and, during its mission, sent stunning images that would forever change our view of the red planet. Before Mariner 9, astronomers could only dream of what lay beneath the Martian surface. Ground-based telescopes revealed little more than blurry spots and reddish tones. How could one imagine that beneath those spots lay one of the most impressive canyons in the solar system? When the probe began sending photographs, scientists noticed a series of gigantic cracks running along the Martian equator. No one expected to find a structure of such magnitude, a chasm that surpassed any known formation on Earth. Why was Mariner 9 able to see what other missions could not? The key was its ability to observe Mars during a global dust storm. At first, the spacecraft saw nothing but a thick, opaque atmosphere. But as the dust settled, the Martian relief began to reveal itself. Among the first details that emerged was this immense system of canyons, later named Valles Marineris, in honor of the probe itself. The discovery was so unexpected that many scientists thought for a time that it was a chain of aligned impact craters until more images confirmed the unique nature of the canyon. The discovery of Valles Marineris not only marked a scientific milestone, but also redefined our questions about Mars. How could such a colossal fracture have formed? What geological and climatic secrets does it hide? Since then, this wound on the Martian surface has been the subject of constant study, motivating missions, theories, and debates. In a sense, Mariner 9 not only discovered a canyon, but also opened a window to Mars's deep history, awakening a new era of planetary exploration.
If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey.
How big can a canyon be on another planet? Valles Marineris breaks any scale we can imagine on Earth. To start, this colossal canyon system stretches approximately 4,000 kilometers. To put it in perspective, that distance is almost equivalent to the width of the entire European continent, from Lisbon to Moscow. Surprising? It doesn't end there. Its maximum width reaches 200 kilometers, which means that in some sections, entire cities could fit side by side without touching. It's as if the Grand Canyon in Arizona multiplied many times over and still couldn't cover the same space. What about the depth? At certain points, the walls of Valles Marineris plunge up to 7,000 meters into Mars. That's deeper than any canyon on Earth and even exceeds the height of Mount Everest, if we imagined placing the mountain upside down from the summit to the base. This Martian abyss not only impresses with its figures, but also with the sense of vertigo and wonder it evokes. Can you imagine standing on the edge of a crack of such magnitude, gazing at a landscape that disappears beyond the horizon? But how does this giant compare to similar formations on our planet? If the Grand Canyon on Earth seems vast and imposing, Valles Marineris makes it look small. The American Canyon measures just over 400 kilometers long and about 24 kilometers wide, barely a tiny fraction compared to the colossal Martian scale. In fact, if Valles Marineris were on Earth, it would cover almost the entire distance from Madrid to Moscow, and its depth would swallow any skyscraper ever built. The dimensions of Valles Marineris challenge the human mind. It is a valley system so extensive and deep that if a person could ever walk through it, it would take months just to traverse its length, provided they could navigate the steep cliffs and vast chasms. This canyon is not only the largest on Mars, but also holds the title of one of the most astonishing geographical features in the entire solar system. Its mere existence forces us to rethink what we consider possible in planetary geology. How far does the greatness of Valles Marineris extend when compared to the famous Grand Canyon on Earth? Many might think that the Grand Canyon in Arizona is one of the greatest geological wonders of the solar system. But the reality is that next to its Martian counterpart, it seems almost tiny. The Earth's Grand Canyon has an approximate length of 500 kilometers, a maximum width of 30 kilometers, and a depth that reaches around 1,800 meters at its deepest points. These numbers are already impressive, but how do they compare to the dimensions of Valles Marineris? Valles Marineris stretches over 4,000 kilometers, which is equivalent to the distance between Madrid and Moscow, or almost the width of the entire European continent. Its maximum width can exceed 200 kilometers, and its depths reach up to 11 kilometers in certain areas, which is 13 times the depth of the Earth's Grand Canyon. If the Grand Canyon were a mere crack, Valles Marineris would be a gigantic wound that cuts across the Martian surface, visible even from outer space. Can Earth boast of such a colossal scar? The scale difference is so vast that if the Grand Canyon were on Mars, it would be just one of the many secondary valleys of Valles Marineris. But the comparison is not just a matter of size. The Grand Canyon has been shaped primarily by the erosion of the Colorado River over millions of years, while Valles Marineris was formed from tectonic forces, collapses, and perhaps the influence of ancient lakes and water currents. This leads us to wonder, what do these canyons tell us about their respective planets? The Grand Canyon is a testament to the constant presence of water and the atmospheric dynamics of Earth, while Valles Marineris reveals the violence and complexity of Martian geological processes, where water may have played only an occasional and brief role. And what about the visual and symbolic impact of both canyons? On Earth, the Grand Canyon is an icon of tourism and popular culture, a postcard recognized worldwide. However, in the context of Mars, Valles Marineris represents a frontier of the unknown, a symbol of the almost unimaginable scale of planetary processes beyond our world. It is an invitation to explore not only the red planet, but also to reconsider our place in the cosmos. Thus, the comparison between these two giants highlights not only differences in size, but also in history, formation, and scientific significance. What is the true home of Valles Marineris on Mars? This colossal canyon system stretches along the Martian equator, like a gigantic scar dividing the red planet into two hemispheres. Located slightly south of the equator, Valles Marineris is found in the region known as the Cuprates Quadrangle, an area that stands out for the presence of other fascinating structures and its proximity to some of the most enigmatic formations on Mars. But why is it precisely there and not elsewhere on the planet? To understand the location of Valles Marineris, one must imagine the Martian surface as a vast topographic map filled with contrasts. To the west of the canyon lies the famous Tharsis Plateau, an elevated region that houses the largest volcanoes in the solar system, such as the imposing Olympus Mons. The proximity of Valles Marineris to Tharsis is no coincidence. Tectonic pressure and crustal movements in this area have been key in the formation of the canyon. If we were to draw a line between the giant volcanoes and the canyon, we would see that Valles Marineris is almost like a wound created by the force of Tharsis pushing and distorting the Martian crust. Did you know that Valles Marineris is oriented from west to east, spanning almost a quarter of the planet's circumference? It's as if there were a canyon on Earth connecting Europe and Asia in a straight line. Its western end begins near the eastern flanks of the Tharsis Plateau, while its eastern end stretches towards the vast plains of Chryse Planitia. a region famous for being the landing site of the legendary Viking 1 probe. This arrangement makes Valles Marineris a kind of natural corridor between the volcanic highlands and the low Martian plains, facilitating the study of the transition between two radically different landscapes. The strategic location of Valles Marineris has also had significant consequences for geological history and Martian exploration. Being so close to volcanic regions, the canyon has witnessed lava flows, landslides, and possible water movements in the distant past. Furthermore, its position at the equator means it receives more sunlight than other areas, favoring observation and study by probes and orbiters. Thus, Valles Marineris is not only a geological monument, but also a privileged window into the deepest secrets of the red planet. Why is Valles Marineris so colossal? The answer lies in its origin, a mystery that has fascinated geologists and astronomers for decades. When one thinks of terrestrial canyons, they generally arise from the slow and constant action of water-eroding rock over millions of years. However, the story of Valles Marineris is much more complex and dramatic. On Mars, this canyon system formed from titanic forces that broke the planet's crust, leaving deep and extensive scars. Scientists believe that the birth of Valles Marineris is closely related to massive volcanic activity in the Tharsis region. Imagine that the Martian crust is like the shell of an egg. If enormous pressure is exerted from within, the shell can crack and open. Something similar happened when the Tharsis Plateau, one of the largest volcanic areas in the solar system, began to rise. The weight and pressure generated by the volcanic material caused the surface to fracture, leading to enormous faults and chasms. Thus, Valles Marineris opened like a gigantic wound along the Martian equator. But was volcanic activity the only culprit? The answer is no. Another theory suggests that after the initial fracture, erosion caused by processes such as wind, minimal water action, and even possible landslides contributed to widening and deepening the canyon. Although Mars is now a dry and cold planet, there is evidence that liquid water may have flowed across its surface in the past. This water, although fleeting, would have further sculpted the walls and floor of the canyon, leaving traces that scientists study in detail today. Additionally, there is debate about whether the interaction between tectonic forces and land collapses generated specific segments within Valles Marineris. Can you imagine a system of cracks that expands on its own, as if the ground were slowly sinking? Thus, the combination of tectonic fractures, volcanic activity, and erosion worked together over millions of years to shape one of the most impressive and enigmatic landscapes in the solar system. The geological formation of Valles Marineris is not just a chapter in Martian history, but a unique window to understand the processes that can transform an entire planet. What is special about Mars's crust that allowed the formation of a canyon system as gigantic as Valles Marineris? The answer lies in Martian tectonic faults, an essential phenomenon for understanding the impressive geography of the red planet. Although Mars does not have active tectonic plates like Earth, it does exhibit colossal fractures and displacements in its crust, caused by internal forces that have shaped its surface over millions of years. It's as if the planet has been subjected to enormous stress, creating cracks that extend over thousands of kilometers. But where does that stress come from? To understand it, one must think of the vast volcanic region near Valles Marineris, the Tharsis Plateau. The weight and pressure exerted by this vast concentration of volcanoes generated forces that literally stretched and broke the Martian crust. Imagine trying to bend a very dry board. At some point, the wood gives way and breaks into large splinters. Thus, the crust of Mars cracked and opened, giving rise to deep fault systems. Valles Marineris is, in fact, the largest of those scars, a fracture that expanded and deepened over time. Are these faults unique in the solar system? In a sense, yes. Martian tectonic faults are not only of impressive magnitude, but they also show complex patterns of fracturing and displacement. Some areas exhibit what is known as graben, blocks of crust that have sunk between parallel fault lines. This phenomenon is visible in several segments of Valles Marineris, where enormous blocks of land have slid downward, leaving vertical walls and flat floors. Scientists have studied these patterns to unravel Mars' internal processes, and each finding provides new clues about the planet's geological evolution. And why is it important to study these faults? Because they allow us to reconstruct Mars' internal history, reveal the intensity of its ancient movements, and understand how a planet can transform without the presence of tectonic plates like those on Earth. The analysis of Martian tectonic faults not only helps explain the existence of Valles Marineris, but also allows for comparisons of the internal dynamics of different worlds. Ultimately, these gigantic fractures are not just scars on the Martian surface, but windows into the planet's deep past, key to understanding the evolution of Mars and the solar system. What makes the Tharsis region so crucial for understanding the origin of Valles Marineris? Tharsis is much more than just a simple plateau on Mars. It is the starting point of some of the most impactful geological processes in the entire solar system. This vast, elevated region, stretching for thousands of kilometers, seems to have been the main engine of the forces that sculpted the gigantic Martian canyon. But how can a plateau influence the geography of an entire planet so decisively? The key lies in the colossal accumulation of volcanic material that characterizes Tharsis. Home to the largest known volcanoes, such as Olympus Mons and Arsia Mons, this region represents a kind of superweight on the Martian crust. As these volcanoes grew, they added enormous amounts of mass, exerting tremendous pressure on the surface. It's like placing a mountain on a cardboard sheet. The plate eventually bends, cracks, and fractures under the weight. This process generated such intense stresses that the Martian crust began to crack, giving rise to gigantic fractures. Thus, the Valles Marineris system was born, right on the eastern flank of Tharsis. Is it possible for a single region to explain such dramatic phenomena? Scientists believe so. Studies suggest that the elevation of Tharsis changed the planet's balance, even altering the orientation of the poles over millions of years. Furthermore, the uplift of Tharsis not only caused the initial cracks, but also influenced the Martian climate, atmospheric circulation, and even the possible existence of ancient rivers and lakes near the canyon. It's as if Tharsis had been the invisible hand that shaped Mars' geological destiny. Could Tharsis hold secrets yet to be discovered? The answer seems to be a resounding yes. The complex interaction between the volcanoes, tectonic faults, and the climatic history of the region remains a fascinating enigma for science. Each new observation reveals unexpected details, such as signs of volcanic activity much more recent than previously thought, or traces of ancient hydrothermal processes. In short, Tharsis is not only the epicenter of volcanic activity on Mars, but also the key piece for understanding how an entire planet can transform over time. What are the true protagonists within the colossal abyss of Valles Marineris? Although at first glance it may seem like a single gigantic crack, it is actually formed by a complex series of main segments, each with its own geological personality. What names do these segments receive, and how do they differ from one another? Let's delve into the mysteries held by Melas, Candor, Ophir, Eos, and Tithonium, the 5 essential sections of this Martian canyon system. Let's start with Melas Chasma, considered one of the deepest and widest valleys in the entire system. Did you know that Melas can exceed 11 kilometers in depth? This is more than 10 times the height of the Grand Canyon in Colorado. Melas is famous for its steep vertical walls and a wide variety of sediments at its bottom, suggesting that it may have once harbored liquid water, or at least very intense erosion processes. Here, scientists have found layers of minerals that only form in the presence of water, making Melas a kind of Martian time capsule. Next, we find Candor Chasma, which stands out for its width and the number of internal structures it exhibits. Candor is so extensive that if it were on Earth, it could cover several European countries. One of the great enigmas of Candor is the presence of sulfate and clay deposits, minerals that, on our planet, are usually associated with wet environments. Could this indicate that Candor was once a Martian lake? Although there is no definitive answer, the possibility continues to intrigue scientists. Ophir Chasma, on the other hand, is like a window into Mars' volcanic past. This segment is characterized by its enormous walls and a series of terraces and platforms that seem to have been shaped both by tectonic activity and erosion. Ophir is also a key point for studying how the planet's internal forces can fracture and deform the crust over millions of years. Its irregular shape and the traces of massive landslides make Ophir a true natural laboratory for Martian geology. No less fascinating are Ius and Tithonium Chasma. Ius is a long and narrow segment, famous for its faults and fractures that run through the canyon like scars. What could have caused these peculiar patterns? The most accepted theory is that Ius was affected by enormous tectonic stresses, perhaps associated with the volcanic region of Tharsis. Finally, Tithonium Chasma, located at the western end, is distinguished by its stepped walls and the presence of dark dunes, witnesses to the continuous action of Martian winds. Together, these 5 segments not only form one of the most breathtaking landscapes in the solar system, but also hold essential clues about the history and evolution of Mars. Did you know that Valles Marineris is not just a single canyon, but an intricate system of fissures, valleys, and branches that extend like the veins of a Martian leaf? Beyond the main segments, the canyon is accompanied by a network of secondary canyons and tributaries that make it even more impressive. These secondary channels, known as chasmas in scientific terminology, act as corridors connecting different parts of the main system, forming a geological structure much more complex than we might imagine at first glance. What is the origin of these secondary canyons? Scientists believe that many of them formed from successive fractures and collapses of the Martian crust, triggered by intense tectonic and volcanic activity in the region. Some, like Noctis labyrinthus, branch out into an intricate network of labyrinthine valleys, as if the surface of Mars had been crossed by enormous cracks in a crystal. Other smaller canyons, like Capri Chasma and Eos Chasma, serve as gateways into and out of the system, extending hundreds of kilometers beyond the limits of the main canyon. What purpose do these branches serve in scientific terms? The secondary canyons are true natural laboratories on Mars. They allow us to study how the planet's internal forces have shaped the terrain and provide clues about erosion processes, sedimentary deposits, and possible routes of ancient water flows. Moreover, the diversity of shapes and sizes in these branches reveals distinct geological episodes, from massive collapses to the slow action of landslides and Martian winds. Thus, each branch tells a different part of the story of the Red Planet. Could these canyons hide even more fascinating secrets? Some researchers suggest that the secondary valleys, due to their depth and the permanent shadows they cast, may have protected deposits of ice or even traces of minerals formed in the presence of water. Exploring these tributaries is like delving into the less read pages of a millennia-old book. Every curve, every fork, could be the key to understanding not only the evolution of Valles Marineris, but also the possibility that Mars once harbored habitable environments in its past. What secrets do the walls of Valles Marineris hide? This colossal Martian canyon not only impresses with its size, but also with the complexity of its internal structures. The canyon walls, at certain points, rise to nearly 8 kilometers in height, forming cliffs that defy imagination. If we compared these walls to the tallest skyscrapers on Earth, they would appear tiny beside them. But beyond the height, what is truly fascinating is what the exposed layers along these walls reveal: genuine open books on the geological history of Mars. What are these walls made of? Mainly volcanic rocks, basalts, and sedimentary materials that have been uncovered after millions of years of tectonic activity, erosion, and landslides. Many of these layers alternate in color and composition, showcasing reddish, yellow, and grey tones. Each stripe represents a distinct era, as if they were the pages of a Martian encyclopedia. Scientists have identified sequences of materials that, on Earth, could only form through the presence of water or intense volcanic processes. Could it be that these layers hold the key to understanding Mars' wet past? But there's more. Along the walls, enormous fractures and terraces can be observed, formed by the collapse and displacement of materials. Some areas feature large fallen blocks and debris, evidencing gigantic landslides that occurred in the past. Why do these massive falls happen? The most accepted explanation is that the instability of the walls, combined with Martian gravity, causes landslides that constantly reshape the canyon. Additionally, in certain sectors, structures resembling caves or tunnels have been detected, likely formed by lava flows that excavated underground galleries millions of years ago. Are there signs of recent geological activity? In some places, deposits of dust and sand have been found accumulating on terraces and ledges, along with grooves indicating still active erosion processes. These details suggest that Valles Marineris is not a static structure, but a dynamic system, constantly transforming. Thus, the walls and internal structures of the canyon not only impress with their appearance, but also stand as silent witnesses to a planet in evolution, holding essential clues about the history and future of Mars. Have you ever wondered how a canyon of such magnitude as Valles Marineris came to acquire its current appearance? The answer is not simple, but erosion processes and other geological phenomena have played a key role in sculpting this Martian colossus. Unlike Earth, where liquid water is the main sculptor of landscapes, the story on Mars is much more complex. Wind, tectonic activity, and to a lesser extent, past water flow have left deep marks on the walls and floors of the canyon. Is it possible that such a gigantic canyon formed solely from plate movements and fractures? Scientists believe not. Although the initial fracturing of the Martian crust opened enormous cracks, it was erosion that widened and shaped these abysses. For millions of years, Martian winds, which can reach astonishing speeds, have carried dust and sand particles, slowly wearing down the canyon walls. It's as if an invisible sandpaper has been polishing Valles Marineris for eons, revealing layers and structures that tell the story of the red planet. But was there ever enough water to leave its mark? Geological evidence suggests that in the past, liquid water intermittently flowed through some parts of the canyon. There are signs of ancient runoff channels and deposits that only water could have left. However, the dominant process today is wind erosion. Imagine the effect of constant wind in a terrestrial desert, only here it occurs on a planetary scale and over millions of years. In addition to the action of wind and the possible passage of water, internal geological processes have also played a fundamental role. Landslides, triggered by the instability of the walls and Martian gravity, have dramatically altered the canyon's relief. These events have not only widened the system, but have also created terraces and debris accumulations at its bottom. The fascinating thing is that, despite the apparent stillness of Mars, Valles Marineris remains a natural laboratory where erosion and geological processes continue to transform the landscape today. In short, erosion in Valles Marineris is the result of a combination of unique Martian factors: tireless winds, ancient water flows, tectonic movements, and gigantic landslides. Each of these processes has left its indelible mark, making this canyon not only a visual wonder, but also a living testament to the complex geological history of Mars. When we think of landslides, we often imagine hills collapsing into the Earth. But have you ever wondered what these phenomena would be like in a world as different as Mars? In Valles Marineris, landslides not only exist, but they reach such monumental dimensions that the largest ones on our planet seem like mere collapses. How massive can these Martian landslides get? Some have covered areas of hundreds of square kilometers, moving masses of rock and dust equivalent to entire cities. What causes these colossal collapses in the largest canyon in the solar system? The walls of Valles Marineris in many places are so steep and high that Martian gravity, although only 1/3 of Earth's, is still enough to trigger gigantic avalanches. The accumulation of loose materials at the edges, the fracturing of rocks due to past tectonic activity, and constant erosion create an unstable balance. A small change, such as a seismic vibration or the weakening of materials after millions of years of exposure, is enough for huge sections of the wall to break off and fall into the abyss. How do we know these landslides occurred? Scientists have identified chaotic deposits of debris at the bottom of the canyon, with rock blocks the size of buildings and grooves that snake for kilometers, marking the path of the avalanches. Some of these scars are so extensive that they could be seen from space with relative ease. Through the analysis of orbital images and digital terrain models, it has been estimated that certain landslides in Valles Marineris moved volumes of material similar to those of the largest landslides in Earth's history, such as the Saidmara landslide in Iran, but multiplied several times over. Could these landslides have occurred recently, or are they relics of a distant past? Research suggests that most of these events took place millions of years ago, when Mars was geologically more active. However, some evidence points to the fact that the process is not entirely over. Small landslides could still occur today due to erosion and extreme temperature changes between Martian day and night. These gigantic avalanches have not only shaped the landscape of Valles Marineris, but have also created unique structures, such as debris fans and overlapping layers of materials that tell us the dynamic and violent history of the red planet. What role do the volcanoes of Mars play in the existence of a canyon as colossal as Valles Marineris? This is one of the most fascinating questions in planetary geology. To understand the relationship, we first need to look at the Tharsis region, located to the west of the canyon. There lies one of the largest volcanic systems in the solar system, with giants like Olympus Mons, Ascraeus Mons, Pavonis Mons, and Arcia Mons. These titans have not only marked the Martian surface with their imposing size, but have also profoundly altered the planet's crust. When these volcanoes expelled enormous amounts of lava over millions of years, the accumulated weight on Mars' crust was colossal. What happens when you press hard on a rigid surface? Sooner or later, that surface gives way, deforms, or fractures. The same occurred on Mars. The pressure exerted by the weight of Tharsis caused stresses that ultimately cracked the crust and generated gigantic faults. Valles Marineris is, to a large extent, the result of that monumental fracture, an abyss that expanded and deepened through the constant interaction of tectonic and volcanic forces. But the volcanic influence doesn't stop there. There are indications that some secondary valleys and branches within the Valles Marineris system may have formed or expanded due to the migration of magma beneath the surface. The heat from the magma may have further weakened the rocks, facilitating subsidence and the collapse of large blocks. Thus, volcanic activity was not only the trigger, but also a silent sculptor that shaped the contours and complex network of canyons. Could the volcanoes have left other traces inside Valles Marineris? Spectral studies have identified deposits of ash and volcanic materials in various areas of the canyon. This suggests that at different times, the region was covered by layers of dust and fragments expelled during eruptions. Altogether, the interaction between volcanoes and geological faults on Mars reveals a dynamic history, where the violence of fire and the planet's internal forces work together to create one of the most impressive wonders of the solar system. When we think of Mars, we often imagine an arid and rocky planet. But did you know that within Valles Marineris lie vast landscapes of dunes and sedimentary deposits? These formations not only beautify the canyon, but are also true time capsules, preserving clues in their layers about the processes that have shaped Mars over millions of years. Martian dunes, although they may appear to be simple mounds of sand, have fascinating stories about ancient winds and changing environments. But how do these dunes form in such a different environment than Earth? The key lies in the fine dust and reddish sand that cover much of the planet. Martian winds, although much weaker than those on Earth due to the low density of the atmosphere, can move light particles and accumulate them at the bottom of the canyon. Thus, over the centuries, these particles have grouped into undulating ridges that snake through Valles Marineris. Some of these dunes reach heights comparable to several-story buildings and stretch for kilometers, creating landscapes that, seen from afar, could be mistaken for earthly deserts. Have these dune fields changed much over time, or do they remain almost intact? The sedimentary deposits within Valles Marineris are even more enigmatic. Layers of fine materials, alternating in colors and textures, tell us of a past where water, wind, and perhaps even volcanic activity played a crucial role. In some areas, the sedimentary layers show repetitive patterns, as if they were the pages of a Martian book. Scientists believe that these formations may have originated from the accumulation of dust brought by storms, volcanic ash, or even materials carried by ancient water flows. What secrets do these sediments hold about Mars's climate and geology? If humans could someday walk along the bottom of Valles Marineris, they would discover that each dune and each sedimentary stratum is a clue about the evolution of the red planet. Analyzing these deposits helps answer key questions. Were there lakes or rivers in the past? How did the Martian climate vary over the ages? Thus, the dunes and sedimentary deposits are not only silent witnesses of time, but also fundamental tools for deciphering the history of Mars and, who knows, perhaps hints of conditions that were once favorable for life. Is it possible that there was once water in one of the most inhospitable places on Mars? This question has fascinated scientists for decades and has driven a genuine treasure hunt in Valles Marineris. If we think of water as the spark of life on Earth, discovering its traces on Mars is not just a geological detail, it could completely change our view of the red planet. The evidence is not mere rumor. There are minerals in the walls and on the floor of the canyon, such as sulfates and clays, that only form in the presence of liquid water or under very humid conditions. How did they get there? Scientists have found layers that appear to have been deposited similarly to sediments in a dry lake, as if Valles Marineris had been, at some point in the distant past, the course of rivers or even the bed of enormous Martian lakes. Observing the arrangement of these layers raises another intriguing question. Was the water of underground, atmospheric origin, or both? The traces of ancient channels and deltas in the internal branches of the canyon further support the hypothesis. These patterns, comparable to those left by rivers in Earth's deserts, suggest that water once flowed with enough force to erode rock and leave indelible marks. Additionally, the fractures and cracks in the canyon walls appear to have been widened by ancient liquid flows, similar to how ice and rain transform landscapes on Earth. This evidence raises an irresistible question. How long did the water flow there and how abundant was it? Space missions have also detected hydrated salts, another indication of past aqueous processes. These salts can form when water evaporates, leaving behind mineral deposits. Currently, although the Martian environment is extremely dry, the presence of these compounds points to a much wetter past. Does this mean that Valles Marineris could have been an oasis in arid Mars? Everything suggests that, at some point, the canyon witnessed cycles of humidity, floods, and even the possible existence of small stable bodies of water. In short, the evidence gathered to date allows us to assert that water played a fundamental role in the history of Valles Marineris. The mineral deposits, eroded channels, and sedimentary layers tell the story of a Mars that was much more dynamic and humid than what we see now. What other surprises will this gigantic canyon reveal about Mars's watery past? The search continues, and each new mission promises to bring us a little closer to the answer. Have you ever wondered how scientists can know what a remote place like Valles Marineris, millions of kilometers from Earth, is made of? The answer lies in a fascinating technique: spectroscopy. Thanks to the light reflected by Martian rocks, orbiters have gathered key information, allowing them to identify the minerals present without having to touch the Martian soil. But what are those minerals? And what do they reveal about the history of this colossal canyon? One of the most surprising findings is the presence of hydrated minerals, meaning those that contain water molecules in their structure. Among them, clays and sulfates stand out, minerals that, on Earth, typically form in environments with liquid water. This suggests that, at some remote point, the interior of Valles Marineris may have been in contact with water, or at least harbored humid conditions conducive to their formation. Sulfates, such as jarosite and gypsum, indicate periods when water, upon evaporating, left these compounds as chemical traces of a wetter past. And what about the minerals that speak to us of volcanic activity? Spectrometers have detected an abundance of iron oxides, such as hematite, which is partly responsible for Mars' characteristic reddish color. Additionally, olivine and pyroxene have been found, minerals typical of basaltic lavas. These materials tell us that the region has been shaped not only by water, but also by intense volcanic activity, likely related to the nearby Tharsis Plateau. It's as if Valles Marineris were a geological library where each mineral is a book narrating a different chapter of Martian history. Spectroscopy has also revealed the existence of silica deposits, a material that on Earth is often associated with hydrothermal processes, such as geysers or hot springs. This clue opens the door to the possibility that, beneath the surface of Mars, there may have existed warm and humid environments, potentially habitable for microbial life forms. Could Valles Marineris have once been home to microscopic life? The answer remains a mystery, but each new spectral finding brings scientists a little closer to solving it. In summary, the minerals identified in Valles Marineris are not only silent witnesses to the processes that have shaped the canyon, but also crucial clues for understanding Mars's climatic and geological evolution. Each new spectral analysis is like another piece in the Martian puzzle, revealing secrets that, until a few decades ago, seemed unreachable. What other mineral mysteries might still await beneath the surface of this Martian giant? Exploration continues, and with each new mission, the canyon's subsurface could surprise us with even more intriguing answers. Did you know that the climate of Mars is one of the key factors that has shaped Valles Marineris over millions of years? While we often think of Mars as a static, frozen desert, the Martian atmosphere, although thin, has been active enough to sculpt and transform this gigantic canyon. But how can such a hostile and tenuous climate have such a profound impact on such a monumental structure? The answer lies in a combination of extreme temperatures, violent winds, and dust storms that sweep across the red planet, sometimes enveloping it completely. Temperatures on Mars can drop to 70 degrees below zero at night, and barely exceed 20 degrees on the warmest day. These thermal fluctuations, much more pronounced than on Earth, cause the rocks on the canyon walls to expand and contract. This phenomenon, called thermal weathering, slowly fragments the rock, making it easier for the wind and other erosive processes to continue their work. Can you imagine the power of nature when, day after day, the cold and heat weaken even the oldest and most resilient stone? Thus, the Martian climate acts as an unyielding sculptor, shaping the walls and floors of Valles Marineris. Another fascinating question is, what role do dust storms play in the evolution of the canyon? On Mars, these storms can be truly colossal, covering vast stretches of the planet and moving fine particles over hundreds or even thousands of kilometers. When the wind carries this dust through Valles Marineris, it acts like natural sandpaper, wearing down exposed surfaces and depositing new sediments at the bottom of the canyon. Furthermore, the suspended dust reduces the solar radiation reaching the surface, further influencing temperature and consequently geological processes. The Martian climate not only erodes, but also preserves. In wetter periods of Mars's past, there was likely liquid water flowing through the canyon. However, with global cooling and atmospheric loss, The dry and cold climate helped preserve many traces of those ancient rivers and lakes, protecting them from further erosion. In a way, the climate of Mars has been both a destroyer and a guardian of Valles Marineris itself, allowing us today to study and marvel at its secrets. Who would have thought that such an apparently inhospitable climate would play such a decisive role in the history of one of the most stunning landscapes in the solar system? The Martian atmosphere, although thin and dusty, is capable of producing surprising phenomena that challenge our understanding of extreme environments in the solar system. What happens when winds sweep across the vast walls and depressions of Valles Marineris? Scientists have discovered that this colossal canyon is the stage for genuine atmospheric spectacles. From dust storms that cover hundreds of kilometers to low fogs that for a moment tint the reddish landscape with mysterious and diffuse tones. Unlike Earth, where humidity and heat trigger rain, on Mars, the protagonist is dust, lifted by air currents that can reach speeds comparable to those of terrestrial hurricanes. One of the most intriguing questions is, how do the dimensions of Valles Marineris influence the dynamics of the Martian climate? Spanning several thousand kilometers, the canyon acts as a natural channel that directs winds and amplifies temperature differences between day and night. This effect, similar to what occurs in terrestrial canyons but on a much larger scale, can generate localized gusts and dust whirlwinds that swirl like genuine miniature tornadoes. These whirlwinds, known as dust devils, can traverse the Martian surface, leaving dark traces visible from space. A reminder that even on an apparently inert planet, the atmosphere is never completely at rest. At times, the conditions within the canyon favor the formation of morning mists, composed of water and carbon dioxide ice crystals. Can you imagine a sunrise on Mars, with the sun filtering through a frozen haze that blankets the depths of the canyon? This phenomenon, although fleeting, suggests that the interaction between the atmosphere and the terrain may be much more complex than previously thought. Furthermore, the topography of Valles Marineris facilitates the accumulation of dust and the formation of banks of fog that can sometimes persist for hours before dissipating with the arrival of Martian noon. But the surprises don't end there. Did you know that electrical discharges associated with dust storms on Mars have been recorded? Although these are not lightning bolts like those that illuminate our skies, electrical signals produced by the friction of suspended particles have been detected, creating a charged environment that could affect the instruments of future robotic or crewed missions. These electrical phenomena, along with gusts of wind and the constant presence of dust, make Valles Marineris a unique natural laboratory for studying the interaction between the atmosphere and the surface under extreme conditions. Thus, the largest canyon in the solar system not only impresses with its size, but also with the atmospheric enigmas that still await deciphering. How cold can a place like Valles Marineris get? The answer surprises even scientists. Temperatures in this gigantic Martian canyon can drop to nearly 120 degrees below zero at night. It's such extreme cold that, if you were there, any exposure without proper protection would be lethal within minutes. However, during the day, the temperature can rise significantly, sometimes reaching about 20 degrees below zero, and even a bit more, depending on the depth and orientation of the canyon. This drastic variation between day and night is one of the most notable features of Valles Marineris. What causes such thermal fluctuations? Mars's thin atmosphere, composed mainly of carbon dioxide and with a surface pressure much lower than that of Earth, barely retains solar heat. Imagine a desert on our planet, but multiplied by 100. Solar radiation quickly heats the surface during the day, but that same energy escapes rapidly when night falls, leaving the canyon engulfed in almost absolute cold. Moreover, the lack of liquid water and the scarcity of clouds mean there is almost nothing to help retain heat in the region. Do these extreme temperatures affect the geology of Valles Marineris? Absolutely. Freezing and thawing cycles can cause the fracturing of rocks. Although water presence on Mars is minimal, changes in minerals still occur due to the sublimation of ice and the expansion and contraction of materials. This process, over millions of years, has contributed to shaping the walls and floor of the canyon, generating cracks and rockfalls that continue to transform the Martian landscape. Could any form of life survive under such conditions? It's one of the big questions in astrobiology. The temperatures of Valles Marineris challenge life as we know it. But some scientists believe that in the past, when Mars was warmer and wetter, certain forms of microbial life may have adapted to extreme changes. Today, any possible organism would have to endure not only the cold, but also extreme radiation and dryness. However, the history of life on Earth teaches us that nature always finds unexpected ways to survive, even in the most inhospitable places in the universe. Is it possible that beneath the surface of Valles Marineris, there are hidden caves or even lava tunnels similar to those we find on Earth? This question has intrigued scientists since the first detailed images of the canyon revealed strange depressions, dark entrances, and collapses in the walls of the system. On Mars, just like on our planet, lava tubes can form when the surface of a volcanic flow cools and solidifies, while the liquid lava continues to flow beneath. When that internal lava finally drains or stops, an empty conduit is left behind, a lava tube. While the interiors of these potential Martian tubes have yet to be explored, geological evidence and orbital images suggest that extensive underground networks could exist in the Valles Marineris region. What significance would these structures hold for exploration and science? On Earth, caves and lava tubes are true natural refuges, protecting against heat, cold, radiation, and even small meteorite impacts. On Mars, the extreme surface conditions make the idea of finding caves not only fascinating, but also strategic. These underground spaces could have provided protection for microbial life in the past, or even serve as potential shelters for future human missions. Could it be that the first human bases on Mars will not be built on the surface, but underground, utilizing these natural tunnels as shields against intense solar radiation? But how can we be sure of the actual existence of these tubes and caves? Scientists have identified circular entrances and collapses in the terrain, known as skylights, which appear to be windows into underground cavities. Additionally, topographic analyses and radar data have identified anomalies and voids in the subsurface of the region consistent with the presence of large lava tubes. Some of these possible accesses have several meters in diameter, enough for a human explorer or even a small robotic vehicle to enter in the future. The possibility that Valles Marineris harbors a network of lava tubes and natural caves makes this region an unparalleled geological and astrobiological laboratory. Exploring these spaces could reveal not only secrets about the volcanic activity of the Red Planet, but also clues about its climatic past and the possible presence of liquid water underground. Could these caves be the hidden archives of Martian history? The truth is that as technology advances, the underground exploration of Mars is shaping up to be one of the next great challenges in the search for life and in the future human settlement on the Red Planet. What are the odds that in some hidden corner of Valles Marineris, life has found refuge? This is one of the most fascinating questions scientists are asking about Mars. Although the current environment is extremely hostile, with frigid temperatures and a very thin atmosphere, the unique characteristics of this colossal canyon have sparked the imagination and curiosity of astrobiology experts. Could its deep valleys and steep walls offer more favorable conditions for life than other Martian regions, perhaps protecting microorganisms from lethal radiation and extreme temperature changes? Valles Marineris is not just a simple canyon. Its size and geological complexity make it a diverse environment where, at least in theory, microhabitats could have formed. On Earth, there are organisms that thrive in extreme conditions, from bacteria living in the depths of underwater canyons to microbes that survive in frozen deserts. Is it possible that something similar has occurred on Mars? Some scientists believe that if there was ever liquid water in the lower strata of the canyon, it could have provided temporary refuges where Martian microbial life had a chance to thrive. away from the harsh conditions of the surface. Research has detected minerals in Valles Marineris that, on Earth, are often associated with the presence of water and chemical processes compatible with life. Could these minerals be the remnants of ancient underground oases? Furthermore, the depth of the canyon may have allowed liquid water to exist for longer than in the surface areas of Mars. In this sense, Valles Marineris would be like a time capsule, preserving conditions that, although they seem impossible today, may have been much more hospitable to life in the past. But is there any possibility that life persists today, hidden in deep cracks or in pockets of brine beneath the surface? Although there is no direct evidence, the search continues. The biggest challenge is accessing those protected environments without contaminating them. If life were to be discovered, even if it were only microbial, it would forever change our view of Mars and the universe. Ultimately, Valles Marineris represents one of the best hopes for answering one of humanity's oldest questions. Are we alone? Why do scientists pay such close attention to Valles Marineris when searching for signs of life on Mars? The answer lies in the unique combination of geological and historical conditions that make this canyon a kind of Martian time capsule. It's not just about its enormous size, but also the diversity of environments it has hosted over millions of years. In its walls, strata, and deposits, Valles Marineris could preserve chemical and physical traces of processes that at some point favored the presence of water, a key ingredient for life as we know it. Is it possible that microbial life once existed inside this canyon? That question has driven research for decades. Astrobiology, the science that studies the origin, evolution, and distribution of life in the universe, finds in Valles Marineris an exceptional natural laboratory. The hydrated minerals found on its slopes and soils indicate the ancient presence of liquid water, and where there is water, the possibility of life increases significantly. Furthermore, the depth of the canyon could have offered refuge against cosmic radiation, creating more stable and protected microenvironments than the exposed Martian surface. But how does Valles Marineris differ from other places on Mars from an astrobiological perspective? Unlike impact craters or ancient riverbeds, this canyon system brings together a variety of geological processes: tectonic fractures, nearby volcanic activity, erosion, and sedimentation. Each of these processes may have left layers of materials rich in information about the chemistry and physics of Mars's past. If microscopic organisms ever existed, it's possible that their remains, or at least the signals of their activity, have been trapped in the rocks and sediments of the canyon, waiting to be discovered. The importance of Valles Marineris for astrobiology doesn't end there. This gigantic chasm also serves as a natural analogue for studying how habitable environments might evolve on other rocky planets in the solar system and beyond. That's why, whenever scientists plan new missions to search for life, Valles Marineris appears as one of the priority regions. In summary, exploring this canyon is much more than studying a geographical feature. It's a glimpse into the deeper possibilities of life beyond Earth. How is it possible that we know so much about a giant canyon located millions of kilometers away from Earth? The answer lies in robotic exploration, one of the most fascinating feats of space engineering. Since the 1970s, probes and orbiters have flown over Mars and directed their electronic eyes toward Valles Marineris, becoming our virtual explorers on the Red Planet. Each of these missions has allowed us to decipher secrets that would otherwise remain hidden beneath the thin Martian atmosphere. One of the first missions that forever changed our knowledge of the canyon was Mariner 9. What was special about this probe? It was the first spacecraft to orbit another planet, and in 1971 it sent the first detailed images of Valles Marineris. These photographs, which at the time seemed straight out of a science fiction novel, showed for the first time the magnitude and complexity of the canyon system. Mariner 9 was like the first explorer who opened a window to the unknown, leaving scientists around the world in awe of the size and structure of the canyon. But have we stopped exploring since then? On the contrary, Orbiters like Viking, Mars Global Surveyor, Mars Odyssey, Mars Express, and the famous Mars Reconnaissance Orbiter have continued the work of observation and analysis. Each one, equipped with more advanced instruments, has provided layers of information that have allowed us to move from simple black and white images to detailed topographic maps, three-dimensional models, and even analyses of the chemical composition of rocks and soils. Thanks to these robots, we can identify minerals, traces of possible ancient water processes, and even track the evolution of dust storms sweeping across the canyon. And how do these probes manage to study such vast and complex terrain? This is where the magic of technology comes in. High-resolution cameras, ground-penetrating radars, spectrometers capable of analyzing light and revealing the composition of materials. Each instrument serves a purpose, as if it were a team of experts working together. For example, the Mars Reconnaissance Orbiter carries a camera so powerful that it can capture details smaller than 1 meter from an altitude of hundreds of kilometers. This makes it possible to detect everything from recent landslides to erosion patterns that tell the geological history of the region. Will there come a day when a robot traverses the bottom of Valles Marineris like rovers do on the surface? For now, the extreme topography and steep slopes make sending a land vehicle a colossal challenge. However, robotic exploration has proven to be an irreplaceable tool, paving the way for, perhaps one day, humanity to send not only machines, but also people to the heart of the largest canyon in the solar system. What makes an image of Valles Marineris so striking? It's not just the immensity of its canyons, but the way space probes have managed to capture details that challenge our imagination. Since the first photographs taken by the Mariner 9 mission in 1971, humanity has had the opportunity to observe, almost with childlike wonder, an abyss that runs across Mars like a gigantic scar. Those initial images, although low resolution compared to today's standards, revealed for the first time the magnitude of this colossus and forever transformed our perception of the red planet. As the years went by and technology advanced, the cameras aboard orbiters like the Mars Reconnaissance Orbiter have delivered photographs with an unprecedented sharpness. What secrets have these robotic eyes revealed? Layers of sediment stacked like pages of an ancient book, fractures that look like cracks in glass, and landslides frozen in time. Images have even been captured where sunlight creates elongated shadows, accentuating the depth of the valleys and giving the illusion that the Martian terrain is almost tangible. These snapshots have been essential for scientists around the world to study Mars's geology as if they were walking along the canyon's edge. Did you know that some of the most famous photographs show dust storms spreading across the interior of Valles Marineris, as if a reddish curtain were covering the landscape? These images, taken during different Martian seasons, have not only fascinated due to their beauty, but have also allowed researchers to observe how atmospheric changes transform the canyon's appearance in a matter of days or weeks. Additionally, there are topographic maps generated from thousands of images that show height variations with vibrant colors, making it easier to understand the complex structure of the terrain. But it's not all static images. Time-lapse sequences, captured over years of observation, have allowed us to see how shadows and light slowly traverse the canyon walls, almost like a sundial on a planetary scale. Each photograph is much more than a simple Martian postcard. It is a window into the past and present of the largest canyon in the solar system. Thanks to these visual records, humanity has been able to marvel at and, at the same time, delve deeper into the study of one of the most breathtaking landscapes ever seen outside of Earth. What tools do scientists use to unravel the secrets of Valles Marineris from millions of kilometers away? The answer lies in an impressive array of space observation technologies designed to capture everything from the tiniest details to the most colossal landscapes of the Martian canyon. Orbiters, for example, function like artificial satellites that circle Mars, carrying high-resolution cameras. Some of these cameras, like the famous HiRISE, can distinguish objects as small as half a meter in diameter, revealing details that once seemed unreachable. It's as if we had a gigantic magnifying glass floating above the red planet, capable of analyzing cracks, dunes, and rock layers with impressive precision. But observation is not limited to images in the visible spectrum. How do scientists manage to see what the human eye cannot capture? This is where spectrometers come into play, instruments capable of breaking down the light reflected from the canyon's surface to identify the chemical and mineralogical composition of the terrain. Thanks to them, we can know if a certain area contains gypsum, iron oxides, or clays, materials that tell stories about the past presence of water and the geological evolution of Mars. It's like having a portable laboratory in orbit, conducting remote analyses of every corner of Valles Marineris. Ground-penetrating radars represent another revolutionary advancement. Is it possible to explore what lies beneath the surface of the canyon without drilling a single hole? With these radars, waves are sent that penetrate the Martian soil and bounce off different internal layers, allowing scientists to see hidden structures, ancient deposits, and possible lava tunnels beneath the surface. This method is similar to taking an X-ray of a patient, except the patient is a Martian canyon thousands of kilometers long. Missions also employ laser altimeters to accurately measure the height of the walls and the depth of the valleys. Why is it important to know this data? Because it helps reconstruct the history of how the canyon was formed and how it has changed over time. Each technology used is like another piece in the puzzle, providing unique and complementary information. Thus, through a combination of cameras, spectrometers, radars, and altimeters, scientists manage to unravel the mysteries of Valles Marineris without ever having set foot on its surface, demonstrating that space exploration is, for the most part, a matter of technological ingenuity. Valles Marineris hides secrets that, to this day, challenge the ingenuity of science. Why is this canyon so extraordinarily large on a planet that, compared to Earth, seems much more tranquil and cold? Scientists are still debating the exact mechanisms that could have sculpted it. Was it a colossal fracture caused by internal tectonic forces, or the result of a series of cataclysmic events, such as massive volcanic eruptions, or the sinking of the Martian crust? Each hypothesis opens new questions and expands the mystery surrounding Mars's true geological history. Another fascinating enigma revolves around the presence of water in the canyon's distant past. Chemical signals and formations have been found that suggest the action of liquids, but it is still uncertain whether those processes were generated by liquid water flowing through the canyon, or if they are deposits formed by other mechanisms. Could there have been a Martian river as impressive as the Earth's Amazon, coursing through these reddish abysses? The absence of direct evidence of permanent flowing liquid water keeps this mystery alive. The inner walls of the canyon also hold clues that remain unsolved. Overlapping layers of materials, signs of massive landslides, and strange geological structures raise questions about the speed and nature of the processes that formed them. Is it a slow evolution over millions of years, or sudden and violent events that transformed the region in the blink of an eye? The lack of precise data on the chronology of these phenomena makes it difficult to reconstruct the true past of Valles Marineris. Finally, a troubling mystery is the possible existence of hidden underground conditions beneath the canyon. There are indications of lava tubes and possible deep caverns, places that may have remained protected from the harsh Martian environment. Could these refuges be the ideal settings where Martian life, even in microbial form, might have found an opportunity to develop? The answer to this question could radically change our view of Mars and the potential for life on other worlds. Each unanswered question turns Valles Marineris into a true natural laboratory, full of enigmas waiting to be deciphered. How can scientists decipher the secrets of such a colossal canyon when they have never walked on its surface? The answer lies in simulations and digital models, key tools for exploring the past and future of Valles Marineris. Using supercomputers, experts recreate complex scenarios based on data obtained from probes, satellite images, and spectral measurements. These simulations allow us to observe, in a matter of seconds, processes that occurred on Mars over millions of years. It's like watching a sped-up documentary where geological forces sculpt the Martian landscape before our eyes. What kind of mysteries can be solved with these simulations? For example, scientists wonder whether the canyon was formed by the collapse of the crust, or if erosion played a more significant role. To find answers, models are created that mimic the planet's internal pressure, volcanic activity, and the movement of Martian tectonic plates. In this way, they can compare virtual results with real canyons, adjusting variables such as temperature, gravity, or the presence of water. Thus, each simulation acts as a kind of virtual Martian laboratory where researchers test their hypotheses. Simulations not only help to understand the past, they also allow us to anticipate the future of the canyon. What would happen if Mars experienced extreme climate changes? How would landslides or new fractures affect the landscape of Valles Marineris in the coming millions of years? Thanks to these models, scientists can predict the evolution of the canyon and assess potential risks for future human or robotic missions. It's as if we had a digital time machine that shows us both the ancient history and the possible futures of this Martian giant. Finally, simulations and models have been fundamental in discovering details that would be impossible to capture with images alone. For example, they have revealed the likelihood of hidden cavities beneath the surface, pathways where liquid water may have flowed, or the location of mineral deposits that could be key for astrobiology. Each new simulation is a window into scenarios that have yet to be observed on Mars, but could become crucial targets for future exploration. Thus, the combination of technology, creativity, and scientific rigor makes simulations indispensable allies in unraveling the enigmas of Valles Marineris. How can a canyon reveal the history of an entire planet? Valles Marineris is much more than just a simple crack on the Martian surface. It is like the geological diary of Mars, written over millions of years. Its walls, exposed like the pages of an ancient book, hold clues about eras of intense tectonic activity, volcanic episodes, and even possible catastrophic floods. Each layer of rock represents a distinct chapter from ancient times when Mars was a dynamic and possibly wet world, to the present, where dryness and cold dominate. Did you know that scientists can deduce the evolution of the Martian climate by observing the sediments and minerals trapped in the depths of Valles Marineris? For example, the presence of sulfates and clays indicates that at some point water flowed or seeped through these rocks, leaving indelible chemical traces. Thus, Valles Marineris narrates Mars's transition from a possibly habitable planet with wet environments to a frozen desert. The traces of ancient landslides, volcanic layers, and dust deposits record environmental changes with astonishing precision. But what is the origin of this colossus? By analyzing the structure and fractures of the canyon, experts have discovered that Valles Marineris arose as a result of gigantic internal stresses of the planet, associated with the uplift of the Tharsis region. This monumental geological event not only opened the canyon's cracks, but also altered the course of Martian history. The canyon bears witness to ancient volcanic eruptions, earthquakes, and erosive processes that have shaped the face of Mars as we know it today. The importance of Valles Marineris goes beyond its size. It is a direct window into Mars's past, a natural archive that helps scientists reconstruct events that occurred hundreds or even billions of years ago. Could this canyon one day reveal whether Mars was truly a world capable of harboring life? The answers may be hidden among its strata, waiting to be deciphered by future generations of explorers and scientists. Thus, every time we look at Valles Marineris, we not only observe a geological wonder, but also the silent testimony of Mars's complex and fascinating history. What happens when a meteorite impacts the Valles Marineris region? This question is more fascinating than it seems. While one might think that such a vast and deep canyon would remain immune to external effects, the reality is that the history of Valles Marineris is marked by the imprint of countless impacts. Mars, unlike Earth, lacks a dense atmosphere that slows down and disintegrates most meteorites. Therefore, every object that crosses the Martian sky is much more likely to reach the surface intact and leave its mark, even within the depths of this colossal canyon. Is it possible that impact craters have modified the very structure of Valles Marineris? The answer is yes. Over millions of years, the constant bombardment of meteorites has left scars on the walls and floor of the canyon. Some of these craters are unimaginably large. They can range from a few tens of meters to several kilometers in diameter. The overlap of smaller craters over older ones reveals a visual chronology of the incessant bombardment, as if it were a constantly changing mural. In certain areas, impacts have triggered landslides and avalanches, altering the original morphology and creating new geological forms. But what consequences does a large impact have within the canyon? It's not just about the formation of a crater. The force of the collision can fracture rocks, open new cracks, and raise dust that remains suspended in the thin Martian atmosphere for weeks or even months. Like throwing a stone into a lake, the effect of a meteorite can propagate for kilometers, causing vibrations that weaken the canyon walls and sometimes trigger chain collapses. These events have left visible traces that scientists study to reconstruct the geological history of the region. It is intriguing to think that some of the most interesting minerals found in Valles Marineris, such as olivine or sulfates, may have been exposed thanks to these impacts. Additionally, impact craters often act as natural traps for dust and sediments carried by the Martian wind. In the past, these craters may have even served as temporary reservoirs of water or ice, providing unique environments for Martian chemistry. Thus, each strike of a meteorite not only alters the landscape, but also reveals hidden layers of Mars history, turning Valles Marineris into an open book, written through cosmic impacts. To what extent will meteorite impacts continue to shape this Martian colossus? Although today the rate of impacts has decreased compared to the early days of the solar system, Mars remains an open target for wandering objects from space. Each new impact, no matter how small, adds another chapter to the complex history of Valles Marineris, reminding us that in the universe, nothing remains static, and that the largest canyon in the solar system continues to be an active stage of change and transformation. What do space explorers and storytellers have in common? Both are irresistibly drawn to the mysteries of remote places, and Valles Marineris has not escaped the imagination of writers, filmmakers, and video game designers. Why has this Martian canyon, with its colossal dimensions and overwhelming atmosphere, captivated popular culture so much? The answer lies in its ability to evoke epic landscapes and settings that seem straight out of a science fiction epic. For decades, Valles Marineris has been a source of inspiration for novels and tales of interplanetary adventures. For example, in science fiction literature, this gigantic canyon often appears as the ideal setting for hidden human colonies, secret bases, or alien enclaves. Authors like Kim Stanley Robinson, in his famous trilogy about Martian colonization, imagined entire cities nestled in the protected walls of Valles Marineris, using its depth to shield colonists from radiation and dust storms. Could this canyon one day be the refuge of the first inhabitants of Mars, just as writers have dreamed? In the world of cinema, Mars and its landscapes have been the stars of numerous films, and although the Red Planet has had many representations, Valles Marineris often stands out as a symbol of the inhospitable and the grand. Movies, like Mission to Mars and Red Planet, have depicted canyons that evoke, albeit fictitiously, the enormity and mystery of this Martian system. This canyon not only appears as a backdrop, but as a character in its own right, capable of shaping the narrative and the fate of the protagonists. What challenges and secrets could a chasm as deep and extensive as this hide? Video games, for their part, have found in Valles Marineris a perfect playground for exploration and adventure. Titles like Surviving Mars and Red Faction have recreated Martian geography, allowing players to virtually traverse the depths and walls of this canyon. For many, exploring Valles Marineris from the comfort of a screen is a way to experience the thrill of space exploration and dream of futures where humanity conquers such extreme landscapes. Can you imagine traversing miles and miles of Martian terrain with your avatar, feeling the solitude and majesty of a canyon so vast that it would make the Grand Canyon of the Colorado seem small? Even in visual art and music, Valles Marineris has left its mark. Illustrators and concept artists have captured their vision of this canyon in posters, book covers, and album art, always highlighting that air of mystery and grandeur that characterizes it. The canyon has become synonymous with the unknown and the limits of the possible, a constant reminder that, although science allows us to understand its origin and evolution, human imagination continues to find in it an inexhaustible canvas to create futures, stories, and adventures. Who knows how many new works Valles Marineris will continue to inspire in the coming generations? Have you ever wondered what it would be like for humans to explore a chasm as gigantic as Valles Marineris? The possible routes for human exploration in this colossal Martian canyon are not just simple lines drawn on a map, but challenges that require engineering, creativity, and a lot of preparation. Valles Marineris, with its thousands of kilometers in length and depths exceeding 7 kilometers, presents obstacles comparable to crossing the Himalayas and the Grand Canyon together, but in a hostile and distant world. Where would the first explorers begin? Scientists and mission planners have considered several options, each with marked advantages and disadvantages. One of the most studied routes would be to descend through the natural slopes formed by ancient landslides. These inclines, although dangerous, offer gradual access from the outer plains to the bottom of the canyon, avoiding the vertical cliffs that would challenge even the best climbers on Earth. Another fascinating alternative is to approach the canyon from its ends, where the topography is less steep and the elevation changes are more gradual. This strategy would allow the deployment of pressurized vehicles capable of moving through the canyon's interior, acting as mobile laboratories that would explore new terrain with each kilometer. Advanced. What if the key lay in taking advantage of ancient tributary valleys? The secondary channels that flow into the main system of Valles Marineris could serve as natural corridors, facilitating the arrival of equipment and supplies. Just as terrestrial pioneers followed riverbeds to venture into unknown territories, Martian explorers could use these valleys as access and evacuation points in case of emergency. Furthermore, these corridors would be ideal for establishing base camps, partially shielded from the extreme temperature variations and intense Martian solar radiation. However, any chosen route will face monumental challenges, from dust storms capable of reducing visibility to zero to hidden cracks beneath the surface that could endanger vehicles and astronauts. That's why current plans contemplate the combined use of exploratory robots and aerial drones to accurately map the terrain before the first human team arrives. Will it ever be possible to traverse Valles Marineris as if it were an interplanetary highway? The dream of crossing this geological titan, traversing its plains, scaling its walls, and unveiling its secrets is getting closer. But only time and technology will tell which routes the first humans will dare to explore in the Great Canyon of Mars. How dangerous would it be to explore the largest canyon in the solar system? At first glance, the idea of descending into Valles Marineris may seem like an exciting adventure, but the reality is much more challenging and, in many ways, terrifying. One of the main risks lies in the canyon's very structure. Its walls are so steep and high that any rockfall could trigger colossal avalanches, capable of burying any equipment in seconds. Landslides, known for leaving gigantic scars over millennia, are not only frequent, but also unpredictable. If on Earth these events can devastate entire regions, on Mars, With no dense atmosphere or vegetation to stabilize the ground, the effects can be even more catastrophic. But the dangers don't end there. What about the Martian atmosphere? With a pressure barely 1/100th of that on Earth, protection against solar and cosmic radiation is virtually non-existent. Explorers would be exposed to radiation doses that, accumulated over weeks or months, could easily exceed safe limits for human life. Even dust storms, which can engulf all of Mars for weeks, pose another monumental challenge. Fine particles can damage electronic equipment, clog filters, and reduce the efficiency of solar panels, jeopardizing the energy needed for survival. How can an operational base be maintained when the very environment conspires against technology? Extreme cold is another silent enemy. Temperatures at the bottom of the canyon can drop below -120 degrees Celsius during the Martian night, instantly freezing any unprotected material. Spacesuits and habitats would need to be true thermal fortresses, much more resilient than those used on the International Space Station. Additionally, the sharp temperature changes between day and night create stress on structures and materials, increasing the risk of failures and cracks. Would it be possible to design technology that can withstand such punishment, day after day, year after year? Finally, communication presents an additional obstacle. The enormous walls of Valles Marineris can block radio signals, making coordination with orbiters or with Earth difficult. In case of an emergency, delays in responses or loss of contact could be fatal. This is compounded by the difficulty of evacuating quickly in such a hostile and rugged environment. Overall, exploring Valles Marineris involves facing a combination of natural and technological dangers that challenge everything we know about survival beyond our planet. Are we really prepared to confront the risks of venturing into one of the most extreme and enigmatic places in the solar system? Could it be possible for humans to one day live inside Valles Marineris? This question has intrigued both scientists and space enthusiasts, and the answer is as complex as it is fascinating. Valles Marineris, with its immense size and depth, could offer unique advantages compared to other regions of the Red Planet. For example, its walls and natural cavities would provide some protection against cosmic radiation and solar rays, one of the major obstacles to life on Mars. On the Martian surface, the atmosphere is so thin that there is no real barrier against these radiations. But inside the canyon, the rock and cliffs would act as a natural shield. Could this be the ideal refuge for the first human colonies? However, Valles Marineris does not only have advantages. Establishing a habitat there would be a monumental challenge. Temperatures can reach extremely low values, dropping well below 100 degrees below zero during the Martian night. Additionally, the atmospheric pressure at the bottom of the canyon, while slightly higher than that of the Martian surface, is still a tiny fraction of Earth's. This means that any habitat would have to be completely sealed and pressurized, similar to a spacecraft, with advanced life support systems capable of maintaining oxygen, temperature, and humidity at appropriate levels. Could we really build indoor cities, protected by kilometers of Martian rock? Another significant challenge would be access to essential resources. Although there are indications of mineral deposits and possibly water ice in some areas of the canyon, extracting and utilizing these materials would require technologies not yet tested on Mars. Transporting equipment and supplies from orbit or from the Martian surface to the bottom of the canyon would be a true engineering feat. Moreover, landslides and other geological phenomena could pose unexpected risks to any human structure. Would it be possible to anticipate these dangers and build infrastructures capable of withstanding them? On the other hand, living in Valles Marineris could also present unique opportunities. The environment, although hostile, is less exposed to the dust storms that plague other regions of Mars, as the canyon walls act as a natural barrier. Furthermore, the great geological and mineralogical variety of the area would offer future inhabitants the chance to study Mars' past firsthand and even search for traces of ancient life in the sediments. If humanity ever decides to settle on the red planet, Valles Marineris could become an unparalleled natural laboratory, a refuge, and perhaps, in the future, a true Martian home. What does the future hold for the exploration of Valles Marineris? Although we know much more about this colossal Martian canyon today than we did a few decades ago, scientists have barely scratched the surface of its mysteries. Will the day come when a robot traverses its walls and sends detailed images of its deepest formations? International space agencies are already planning new, much more sophisticated missions that will seek to answer key questions about the geological past and the possible presence of water or even life in the region. One of the major challenges for researchers is achieving closer and more detailed exploration of the canyon's interior. How can a spacecraft be sent to such a rugged environment, with walls exceeding 7,000 meters in height and unstable soils? To solve this puzzle, robots capable of navigating steep terrains are being developed, similar to the drones and rovers already used on Earth to explore volcanoes or hard-to-reach caves. Furthermore, artificial intelligence will play a fundamental role, allowing these autonomous explorers to make quick decisions in changing or dangerous situations. Could Valles Marineris become the destination for future crewed missions? The possibility is on the table. Some international projects already consider the canyon a strategic point for human exploration of Mars. Its depth could offer some protection against cosmic radiation, one of the main risks for astronauts. However, the technical challenge is monumental. Specialized descent and ascent vehicles will be needed, advanced systems for extracting local resources, and habitats capable of withstanding extreme temperature variations and Martian dust storms. Meanwhile, advances in remote sensing technology promise to revolutionize the way we study Valles Marineris from orbit. Satellites equipped with spectrometers and penetrating radars will allow for the analysis of the canyon's internal layers, revealing hidden information about its history and composition. Will it be possible, in the coming decades, to reconstruct the complete evolution of this Martian giant and decipher whether it ever harbored environments suitable for life? Undoubtedly, the research of Valles Marineris is on the brink of a new era, where each discovery will bring us one step closer to understanding the secrets of the red planet. What makes Valles Marineris so special among the canyons of the solar system? To answer this, we must first understand that it is not the only colossal canyon that exists beyond Earth. However, its size and complexity make it a true giant. Valles Marineris stretches over 4,000 kilometers, which is equivalent to the length of the entire European continent. But are there other canyons in the solar system that can compete with it? One of the most striking rivals is found on Jupiter's moon, Io. There, the canyon called Ma'adim Valles, while impressive, measures about 700 kilometers in length, 1/6 the size of Valles Marineris. On Saturn's moon, Tethys, there is the enormous fracture Ithaca Chasma, which extends nearly 2,000 kilometers. Although this crack is deep and spectacular, its width and depth do not reach the overwhelming scale of the Martian canyon. Even on Uranus's moon, Miranda, the canyon Verona Rupes, stands out with its high cliffs, but its length does not compare to that of Valles Marineris. Why are canyons outside of Mars often less extensive? The answer lies in the geological processes that have shaped each celestial body. For example, Ithaca Chasma on Tethys likely formed when the moon's crust fractured as its interior froze, while Verona Rupes could be the result of impacts and tectonic activity. In contrast, Valles Marineris appears to have arisen from a unique combination of tectonic forces, volcanic activity, and erosion, allowing for the creation of an unparalleled structure in the solar system. Could there be an even larger canyon hidden on some distant moon? So far, no other known canyon comes close to the majesty of Valles Marineris. Its size surpasses not only any terrestrial canyon, but also all those identified on nearby planets and moons. This difference is not just a matter of dimensions, but also of the geological history that each one tells. Each canyon on each world is a testament to the violent and fascinating processes that have sculpted the solar system. But Mars's canyon remains, for now, the undisputed king of planetary abysses. What makes Valles Marineris so essential for planetary geology? When scientists seek to understand the history and evolution of planets, they need windows that allow them to glimpse into the deep past of those worlds. Valles Marineris is precisely one of the largest and most revealing windows in the solar system. Its exposed walls, stretching for thousands of kilometers, allow us to read the geological history of Mars as if it were an open book, showcasing layers and structures that would otherwise remain hidden beneath the surface. This is fundamental because each stratum tells a distinct chapter about the climate, volcanic activity, and tectonic processes that have shaped the red planet. Why is Valles Marineris so special compared to other canyons in the solar system? Unlike other geographical features, this colossal system of canyons stands out not only for its size, but also for the complexity of the processes that have formed it. Analyzing its formations is like studying the scars of Mars. It reveals the interaction between volcanism, crustal fracturing, and erosion, all in one place. This allows scientists to extrapolate what they learn on Mars to other worlds, helping to interpret similar features on distant moons and planets. How has the study of Valles Marineris changed the way we understand geology beyond Earth? Before its discovery, it was believed that complex geological processes, such as tectonics and large-scale erosion, were exclusive to Earth. However, examining Valles Marineris has shown that other planets can also experience internal and external forces capable of sculpting monumental landscapes. This revelation has broadened the horizon of planetary geology, forcing a reconsideration of how mountains, canyons, and valleys form in environments radically different from our own. Moreover, Valles Marineris serves as a natural laboratory to test hypotheses about planetary evolution. For example, how do extreme climate changes influence the stability of canyon walls? What clues do minerals and sediments leave about the presence of water in the past? The answers found here not only enrich our knowledge about Mars, but also provide keys to understanding the history of Earth and the possibility of finding life or habitable environments elsewhere in the universe. Thus, this gigantic canyon is not just a Martian phenomenon, but a central piece in deciphering the deepest secrets of planetary geology. There are secrets in Valles Marineris that challenge even the imagination of those who have studied Mars for decades. Did you know that if the canyon were on Earth, it would stretch from coast to coast across the United States, surpassing the length of any river system known to humanity? This Martian abyss, over 4,000 kilometers long, could house the Himalayas within it and still have space left over. But how is it possible that such a structure formed on a planet so different from ours? One detail that often goes unnoticed is the incredible variety of colors displayed by the canyon walls. From reddish and ochre tones to blue and green hues, these colors are not only a visual spectacle, but also reveal the presence of different minerals and unique chemical processes on Mars. What does this tell us about the history of the red planet? That in its rocks is written the memory of ancient volcanic eruptions, possible floods, and chemical reactions that we still do not fully understand. Can a Martian canyon produce echoes? Although Mars' atmosphere is much thinner than Earth's and transmits sound very differently, scientists believe that if someone shouted at the bottom of Valles Marineris, they might hear a faint and distorted echo, as if the very geography were whispering secrets from the past. Moreover, the differences in pressure and temperature within the canyon are such that they could create microclimates, something surprising on a planet considered inhospitable. Another fascinating curiosity is the existence of mists and fogs that occasionally descend the canyon slopes at dawn. These mists, formed by dust particles and ice crystals, could resemble the fog banks that cover earthly gorges at the start of the day. But what would happen if a human ever peered over the edge of Valles Marineris? They would see a landscape unlike anything on Earth, an abyss so vast that the horizon would seem to curve upon itself, and shadows would play among the folds of the terrain, as if Martian nature were silently telling an ancient story. Finally, it is worth asking, could Valles Marineris have been, at some remote time, a refuge for Martian life? The layers of sediments and hydrated minerals suggest that the canyon has experienced much more dynamic stages than we can observe today. Does it hold within its depths fossils of an unknown past? For now, the answer remains hidden within its walls, waiting to be discovered by future generations of explorers. What makes Valles Marineris so extraordinary among the canyons of the solar system? This colossus is not simply a crack in the Martian surface, it is a planetary scar that stretches nearly 4,000 kilometers, with depths exceeding 7 kilometers, and widths that, at various points, reach 200 kilometers. If one were to traverse it from end to end, it would be like traveling from the east coast to the west coast of the United States, but facing an abyss that would make the Grand Canyon of Colorado seem like just a modest ditch beside it. Is it possible to imagine the variety of landscapes contained within this Martian titan? From vertical walls that rise like petrified skyscrapers to vast plains covered in reddish dunes and sedimentary deposits that record millions of years of planetary history. There are places where landslides have left fresh scars, and others where erosion has sculpted whimsical shapes, as if an invisible sculptor had been working for eons. The segments of the canyon, such as Malus, Candor, and Ophir, each present their own geological character, offering a mosaic of colors, textures, and formations that no other known canyon can match. But what secrets do the depths of Valles Marineris guard? Evidence of minerals that only form in the presence of water has been detected. Clues of ancient lakes or rivers that may have once flowed through its shadowy valleys. Some theories suggest the existence of hidden caves or lava tubes, possible refuges for microbial life from the past. Even today, geological activity and atmospheric phenomena like dust storms continue to transform the canyon, making this place an unparalleled natural laboratory for understanding the evolution of Mars and, by extension, other worlds. Could Valles Marineris be a destination for human exploration in the future? With its colossal size, mineral resources, and the protection its walls offer against cosmic radiation, this canyon is not only a natural monument, but also a window into the deepest mysteries of the red planet. Every corner of Valles Marineris invites us to discover more, to question what we know about the formation of planets, and to dream of what still remains to be explored in that Martian abyss, the largest in the solar system. What is the true meaning of an abyss like Valles Marineris? This Martian colossus is not just a scar on the surface of Mars, but an open book that narrates the story of the titanic forces that have shaped an entire world. In its cracked walls, scientists find chapters of dormant volcanoes, rivers that may have flowed millions of years ago, and signs of tectonic movements that, although different from those on Earth, have left indelible marks. It's as if the red planet has laid bare its most intimate geological diary, waiting for humanity to decipher it. Could this gigantic canyon be the key to answering some of the most important questions about life in the universe? If Mars ever hosted life, it's likely that the clues are hidden among the minerals and sediments of Valles Marineris. Each layer of rock is like a page frozen in time, holding secrets about ancient climates, the presence of water, and perhaps even the possibility of biological echoes that we do not yet understand. It's fascinating to imagine that, at the bottom of this Martian abyss, could lie the answers to questions humanity has pondered for centuries. Are we alone? Is life a universal phenomenon or an improbable miracle? The exploration of Valles Marineris not only represents a technological and scientific challenge, but also a collective dream. Just as the great cathedrals of the past were symbols of humanity's search for meaning, this canyon is an invitation to transcend boundaries and look beyond our planetary home. The interest in this place is no coincidence. Those who study its mysteries become detectives of another world, piecing together clues that range from Mars's geological history to the future of human space exploration. Each discovery in this canyon system redefines what we know about planet formation and the dynamics of the solar system. So, what does the future hold for the exploration of this colossal abyss? Valles Marineris will continue to be one of Mars' greatest enigmas and treasures, challenging engineers, scientists, and dreamers alike. Perhaps one day, a human base will settle in its depths, and the first earthly footprints will be imprinted in its reddish dust. Until then, this canyon remains a reminder of how much we have yet to discover, and that, on the grand stage of the cosmos, every answered question opens the door to new mysteries.